I'm Anil Kumar. Welcome to the challenge of the day. Let me thank all my viewers and subscribers for watching these videos and participating actively. You're also encouraged to post your own questions, so I could pick up one of your questions for challenge of the day. The question for today, the 10th of February 2019 is: a watch loses X minutes every Y hours. At this rate, how many hours will the watch lose in 1 week? Means 7 days. 4 options are given to you. So take your time, answer this question within 24 hours. Post the option in the comments below. Right? Now, let's look into the solution of our yesterday's question, correct? Here is our yesterday's challenge of the day. The river is 48 meters wide and is flowing with the speed of 1.4 meters per second. So this is 48 meters wide flowing. So we showed this arrow by flowing at the rate of 1.4 meters per second. A boat travels in a straight line from point P to Q. So this point is P and this point is Q, right? Directly across. Given that the boat takes 10 seconds, so this time taken T is 10 seconds to cross the river, find the speed of the boat in still water. And the second question was the angle to the bank, so this angle at which the boat should be steered, right? Now, because of the water current, the boat will be pushed down, so you need to steer in a direction at an angle as shown here. We need to figure out what that angle should be so that the boat lands exactly at a point directly opposite. Okay, so that was the question for you. Let us see how to solve this question. Now we need to understand a concept of relative velocity. If I have a person standing outside, then for this person, what is seen is the boat going from P to Q. Do you see that? So that is the resultant velocity, right? That is the resultant velocity. But the boat actually goes in this direction. So if you see the boat, it will be shown in this direction. The head of the boat will be pointing in this direction, but it will be moving straight along this line, right? So that becomes your speed of the boat in still water, right? So we sometimes refer to this as boat speed with reference to water, right? So that is in still water. So we need to find this velocity. You get the idea, right? So the speed of the boat in still water will mean that velocity. Perfect. So I hope that concept is clear. Not this velocity, right? This is the resultant velocity. Well, to find the still water speed, we need to find the resultant velocity also. So we know the distance and time, and we know that distance is speed into time, and so we can find what speed is. So speed is distance over time. So in our case, we can find directly the resultant velocity is distance of 48 meters divided by the time taken as 10 seconds. So we get 4.8 meters per second, which is VR, which is not the option. We need to find what VB is. You get the idea? So we have to use Pythagorean theorem to find the hypotenuse. That has to be much more than this, right? So to find VB, let me write down here. So we know VB, or velocity of boat with water, which is also in still water, should be equal to a square plus b square is c square, right? So will be 4.8 square plus this square, which is 1.4 square. That is that square. So we'll do square root because there's less space. I'm making a shortcut here. You get the idea, right? So we'll use square root of this and then find. So it is equal to 4.8 square plus 1.4 square, and then we'll do square root of this number, which was 25, and we get our answer as 5.0. You get the idea? So it is more than that we are, right? So 5.0 is the right option. So I hope you understand how we got it. So some students might have done a mistake in taking only this velocity. Perfect. Still water velocity is the direction in which the boat was heading. Correct? Now, let's do part 2, which is the angle to the bank at which the boat should be steered. Now, this is the angle theta. So, if you see these two sides are parallel, so this angle is also equal to that angle theta. Right? Now, if you look from this side, then the opposite side is VR and adjacent is given to you, right? So we can use the ratio of these two sides to find theta. So we can say tan theta, which is the ratio of opposite side, which in our case is 4.8, not the time, right? We are looking into the velocities, right? The speeds. So it is 4.8 divided by 1.4. Right, 1.4. So now we can do theta as tan inverse of 4.8 divided by 1.4 to get our answer. Perfect. So we get shift tan inverse of 4.8 divided by 1.4 equals to 73.7. So 73.7 is the last option, right? So that is the angle, and that is also equal to the angle at which the angle which the boat heads with the bank. Do you understand? So that is that option, and that is how you get it. Perfect. Now you could have also found using sine or cosine if you consider that angle, I mean that side, hypotenuse. So either way, so I hope you get the concept. So that is how we will find solution to this relative velocity. I will also provide you with a link on relative velocity where we'll have some very interesting questions. So we'll have tips, right, say, where we'll have thinking questions which will involve cosine law and sine law. So this was relatively a simple question where directly we were working with a right triangle, and so you could use Pythagorean theorem and the trigonometric ratios and simply find the answer, right? So this could be the simplest question in this category. Now, I will encourage you to look into the link provided here to understand how to solve such questions when the angles involved will make a triangle which is not a right triangle. I hope that makes sense. And I hope this is a good learning process for you, and such questions will help you get into very good universities since they are normally asked in such competitive exams. Feel free to make your suggestions, write your views, share my videos with your friends. If you like and subscribe to them, that'd be great. Thank you and all the best.